combining like terms, lesson 15 and a half. So we're going to look at putting terms together within an expression and how we can do that. Our I can is I can combine like terms within an expression. So go ahead and put down your I can, and we'll be ready to move on. Don't forget to put your info in your table of contents and your page number. All right, so let's do a little bit of warm up here with some things we already should know. So I want you to take a few moments, read through and solve each of these, and then we're going to go through and check them out. Okay, so it says, first one says, a number decreased x by the sum of 2x and 5. Well, since it says the number is decreased by the sum of those, in parentheses, let's get a better color here. There we go. So, since it says that, in parentheses, we want the 2x plus the 5, right? Now it says a number is decreased by this sum. So since it says decreased by that sum, we're actually going to do x here and subtract this sum from it, because it says the number is decreased by this sum. So we actually have to put the x first to get this. Next part, we had 6 cubed times 2 to the 4th. So 6 cubed, 6 times 6 is 36. And then 36 times 6 gives us 216. 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're just multiplying those together. Let's go ahead and punch that here. So this one should have been 3,356. All right, now we have to put in 3 for each of these. So 3 to the 3rd power, 3 times 3 is 9, times 3 is 27, 27 times 2 is 54. And then 4 times 3 squared. 3 squared would be 9, times 4 is 36. 3 times 3 is 9. And then minus 6. So 54 plus 36 gives us 90. 90 minus 9 gives us 81. 81 minus 6 gives us 75. Applying the distributive property, we're going to take that 3 times everything inside here. So 3 times 10a would give us 30a. If you had 3 times 10a, that's fine, but we can go ahead and put those together. And remember that we have to take that times all of the pieces. 3 times 3b gives us 9b. And the next one, we're looking at the distributive property again to write something equivalent. So with the distributive property, we're looking for things we can take out or multiply by. So f is in both of those. So we can bring f out front. And we can put 11 plus 15 in parentheses. We can actually add that all together and get 26f, right? Because those two things would still come together. Last one, we have 3 for x and 4 for the y. So 6 times 3 gives us 18, plus 21, plus 3 times, 2 times 3 is 6, plus 7 times 4 is 28. Let's see, that gives us inside here, the 6 and the 28 is 34. 34 times 3 gives us 102. So then we have 102, the 18, and the 21 together. So we should have had for that last one 141. Okay. On these, it's really just a matter of paying attention to the pieces and combining everything using what's there and following those directions. So, using the words to realize that based on the way it says it, that decrease means we're going to subtract the sum of the other part, and it comes out of that x. Order of operations telling us to go through and do the exponents first. Going through here, same thing. Exponents got done first. Taking this and distributing it amongst all the things, using the distributive property and actually pulling out an f out of all of those. Here, putting in those values in for each of those variables and solving out. All right, let's talk about putting some stuff together here. Oh, hang on a second. All right. So, if we take a look at these, what do you notice? So everything in the like terms side, everything that's listed has the exact same things with it. Now, it may have different numbers, but we're talking about variables. These don't have variables. They're both constants. These do have variables, but they have the same. These have variables, but they've got the same 3 variables, even though they're in different orders. These have variables too, but they also have squared variables. Take a look at the ones where they're unlike. I'm not surprised to see this, right? Because those aren't the same variables. This has got a variable, this doesn't. This has got RST, this is missing an S. But now look at this. These are considered unlike. Why? Well, the reason why is, think about when you talk about x squared, isn't that like thinking of x times x? So really, I could rewrite this as 12x x y. And this could be rewritten as 4x y y. So for these to be considered like terms, they'd both have to have 2 of one of those parts, right? But since this has got 2 y's and this has 2 x's, even though they have the same variables listed, they're not listed in the same way because of that exponent, which makes the difference here. So because of that, that ends up getting us to our next point, is that you can only combine things that are the same. So you can kind of think of them like shapes. I can put all these triangles together because they're triangles. They can go in a group of triangles. Now it says 5b and 13b, but I can put them in together. Same thing with the circles. They both have y's in them. Now, if we had exponents with either one of those, that would change it. They wouldn't be the same shape. It would be kind of like thinking of a triangle, and then you had a triangle that had an extra side. Well, that's a square, or a rectangle, or whatever four-sided figure you're thinking of. But when you change something here, you're changing the shape. Our constants go together because they're all constants. Okay. All right. Let's go through and simplify a few others. Okay, let's combine each of these. So if I take a look at this first one, we have 5n minus 3n plus 4n. So I can think about and I can keep whatever's there and really just keep that n with it all. So 5n minus 3n gives us 2n, plus 4n actually ends up giving us 6n. These are all a, so we can really just think about whatever the coefficient is in each one. So 12a minus 1a, because even though there's nothing here, it's 1. That makes 11a. 11a plus 8a makes 19a. 13b, 2y, 5b, 3y, and 8. So the y's will go together, the b's will go together. 13b plus 5b gives me 18b. 2y plus 3y gives me 5y. And then I got an 8. There wasn't any other constants. There's an A, there's an A, there's an A. So 8A plus 5A is 13A plus 3 more. So that's 16A. Let's see, I got 2B, and then I've got subtracting 1B. So that would leave us with just a B. And then I've got a plus 31 and a minus 31, which gives me plus 22 at this point. So in every case, it's simply keeping that variable with the parts and putting together the parts that have the same variables to them, or no variable. All right, let's move on here. So what was true about everything we put together? Yeah, they all had the same variable, or they were constants and didn't have any variables. How do we know some terms wouldn't combine? If they didn't have the same variables. If they had the same variables, they were good to go. Did the signs affect the combination? In other words, if it was added or subtracted, did that make a difference? Yeah, the things that were added, we had to add to the other parts, and if there was a subtraction sign in front of it, we had to actually subtract it off. We'll talk more about how that works in the next unit. Let's go through and do some more practice here before we wrap up. Go ahead and simplify all of these. Simplify would just be combining like terms and to make it as few terms as possible. All right, we have 5x plus 6x. That just gives us 11x. 10y minus 4y, 6y. 4n plus 3n plus n would actually give us 8n, because that n by itself would be 1n. 2a plus 8a gives us 10a. And then 6y, and then subtract out 3y would actually still give us positive 3y. So you got whole numbers there. 6 and 4 make 10. Plus 2x and 12x gives us 14x. These are both cubed. I can put those together. That 3x doesn't have any other x's. They're just x. So let's do 3x plus, put the cubes together, 9x cubed plus, and just a straight up 9. Now, if you wrote those in an opposite order, not a big deal. Just as long as you had the same total parts. So to wrap up, when it comes to like terms and combining them, what should we look for? Yeah, they have the same variables, and if there's exponents involved, that each of those variables has the same exponents as well. Addition, subtraction signs, do those stay with the numbers? Yes. If it's something that says plus whatever or minus whatever, you've got to take that plus or minus with it when you put it together. Can we put more than one term together? Yeah, if they have the same things, you could have 6x plus 2x plus 9x plus 12x plus 133x minus 97x plus 400x. Whatever it is, you can put all those things together. Do all the things with the same variable always go together? No. If there is an exponent with that variable and another variable with the same exponent, those can be put together. But if you have another variable that's the exact same, if you have x and x cubed in the expression, those can't go together because those are actually two different things in this situation. Okay. All right. Looks like we are set here with combining like terms. Thanks for watching. Get ready to move on.